Let's take a look at another example where an argument is given, but there's some holes for us to fill in. Let's take a look. So here we're given some information and we're asked to prove something. We're also provided with a little picture. Now you can see the way we traditionally write these arguments out is to, on the left-hand side, give a list of statements, and on the right-hand side, give a list of the reasons why each statement is true. And you can see here there's lots of gaps. Some reasons are missing, here's some statements are missing, and let's see if we could fill it all in. But where we should always start is at the very beginning with the given, what we want to prove, look at a picture if they give it to us, and then think through it, even before we start looking at this. So let's try it together, okay? So, we're given angle 1 and 2 form a linear pair. So if we look at the picture here, we see angle 1 and angle 2, and they form a linear pair. Certainly this figure seems to indicate that, so that looks good. And we're supposed to prove that angle 1 and 2 are supplementary. Remember what that means. That means that the sum of the measures of those angles equals 180 degrees. So let's see if we can use this given information in order to prove this result. Well, in fact, this has already been done for us a little bit, so let's see if we can just sort of add our voice to the argument already here. So, the first statement is that angle 1 and angle 2 form a linear pair. Why is that true? Well, that's actually our given information. So the reason is, bling, given information. Okay, great. So that's pretty straightforward. The next thing, the ray BA and the ray BC form a line. So let's take a look at that. That's BA and BC, and they form a line. Why is that true? Well, that's exactly what it means to actually be a linear pair. So, bling, definition of linear pair. Great, now we are talking. Now notice that the next thing is a little bit weird because the reason's given, we just don't know what the statement is. So let's see what they're trying to say. The measure of angle ABC equals something, and the reason is because of the definition of straight angle. Well, what is the definition of a straight angle? Let's take a look at the measure of angle ABC. What's the measure of that whole angle? Well, if part of a straight angle, so we know that the measure, in fact, is 180 degrees. So we have a 180 degree angle right there, that entire thing. Definition of straight angle. Oh, now here we don't have to do anything at all, but let's read through it to see where the argument and the logic is taking us. So it says the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Now, do we believe that? The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. So that whole sweeped out thing there. Do you think that this measure plus that measure equals the whole thing? Yeah, it makes sense to me. Let's see why. It's just the angle addition postulate. So that's good. So we're in good shape. The next step, we have to give a reason. So the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. Now, why is that true? Well, look, from step 4, we know the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. And from step 3, we know the measure of angle ABC equals 180 degrees. So all I'm doing is substituting for this quantity 180 degrees. So that's just out and out, bling, substitution. Not a big deal at all. And then the big finish, finally, we're going to conclude exactly what we were asked to prove. Angle 1 and angle 2 are supplementary. And why is that? Well, we know that the sum of the measures equals 180 degrees. That's exactly the definition. And so final region is, bling, definition of supplementary angles. And there you have it, an ironclad proof and the justification, the reasons for why that's true. We just proved a result. And I've got to tell you, I think it feels really good.